Good morning everybody, and once again welcome back to the video. My name is Somil and I'll be your host, instructor and mentor for this video. Today we are going to do a complete data engineering project which resembles to a real world project. We will learn how to bring data from Postgres into data lakes using Debezium, Kafka, Hive Metastore, and then we're going to query that using Trino. So let's take a look at the process first. Insert, update, deletes, they all are captured by Debezium Postgres connector and it publishes data into Kafka topic. The DeltaSTreamer operates in a continuous mode, which means after every 20 seconds, it will listen for new messages from the topic. It grabs the messages, it reads the schema of those messages from the schema registry and will ingest the data into our data lake or universal data lake. Throughout this process, it will also sync and catalog the data in HiveMetastore. This allows user to run simple standard SQL query through Trino against their Metastore. The output on the Minio bucket or the output table in the Minio bucket, you can either read as Delta, Iceberg, or Hoodie. You can interoperate between all the three lakehouse format. Not only that, you can also build a multimodal index on the top of this table. Now, the unique thing about this complete project is as soon as you insert or update anything into Postgres, you will see that changes reflecting in data lake in less than 2 minutes. Also, deletes are taken care as well, which means I'll show you in the project as we proceed. When I go ahead and let's say delete sales ID 11, automatically that sales ID 11 would be removed from a Hoodie data lake. So you're going to see all that in action. I'll also show you we'll be querying this data, the real-time data through Trino. So I hope you are excited. This is what we're going to build. This is going to be a little long video where I'll cover every single setting, every single configuration in great detail. So now that you have a background of what we're going to do, so let's get started with the project. All right, so now we are gonna begin the lab session, okay? The only thing that you need prerequisite for this lab is, you need a Docker on your machine, and then you need PySpark install version 3.4.0. You can install by a simple pip command, pip3 install PySpark 3.4.0, right? So now let's start, okay? So as soon as you clone the project repository, okay, you will see all these project folders and files. I'll cover these folders and files in a second. So you will see the first thing that you will see is a Docker compose file. This particular file will be used to spin up all our containers, such as Kafka, schema registry, Trino coordinator, HiveMetastore, Minio. So that's all over here, okay? The next thing that you will see, if you do not see this, you should see a folder called jar. Inside the jar, you should see 3 jar files. If you do not see them on the GitHub, you will see a link to download that. Click on the link, it should navigate you to the Google Drive and download all the 3 jar files. The first jar file that we need is Hoodie utility slim bundle jar. This jar file is used for the DeltaStreamer. Then the next 2 jar files are Hoodie Java client jar and Hoodie extension snapshot jar. So these 2 jars are used by DeltaStreamer to perform the translation of metadata. So which means after every single commit, DeltaStreamer will build the metadata for Iceberg and Delta, which allows us to interoperate either as Hoodie, Iceberg or Delta. So that's why we need these 2 jar files, okay? After that, again in this diagram you see the Debezium, right? Debezium Postgres connector. So the settings used for the Debezium Postgres connector is inside the folder Debezium. There is a file, txt file called Postgres. I'll show you what this is. So again, for now, the settings is inside that. After that, you will see a folder called Postgres script, and inside that you will see data.sql. So when we start up the container, right, we need some tables to play with, right? So this will create a table called sales, and it will basically insert some dummy data into that particular table. Okay, so this is that. Let me close this. Let me close this. Let me close this. And then after that, you will see a file called spark config.property file. This property file has all the settings related to Spark. Here we define our Minio access, Minio secret. We also define our S3A endpoint, etc. So that's the file which will hold all of that. Then all the Spark submit jobs, which means all the DeltaStreamer jobs, is gonna be inside a file called submit Spark jobs, okay? And then you should have an IPython notebook, which we will use to run real-time queries through Trino against our HiveMetastore, okay? And then you have two Python file, read Delta, read Iceberg. So this shows how to interoperate between Delta and Iceberg at the end. So hopefully everything made sense, right, on the project, right? So now let's start, okay? So the first step, what we need to do is, again, assuming you have Docker installed, we will spin up the stack. So simply come inside here, okay? And let me just first, prune everything. So I'm gonna say Docker system prune, and then I'm gonna say Docker volume prune, just clearing up everything, right? And now I'll start all the containers. So now to start the containers, you'll use Docker compose up -- build -t. This should start the following things. I just want to repeat. This will start a Postgres, Kafka, schema registry, HiveMetastore+Trino, and the Minio. Okay, hopefully made sense. Enter. They all are now in the starting state. As you can see, you should see about 6 containers in the starting state. Once this is done, now you need to open up Chrome, and I'll tell you what to do next. Okay, so now let me close this one. Okay, so the first step, open up the URL localhost 9000. The username is admin, then the password is password. Here you see a bucket, a Minio bucket, which will be used to build our universal data lakehouse. After that, open up a new tab, the second tab, head over to localhost, I believe 8080 or 8081, let me see, 8080, and the username is going to be admin. And here you will see your Trino cluster overview. Next, open up localhost 3040. Here you will see schema registry, Kafka topics, Kafka Connect UI, etc. Okay. So hopefully so far you guys are with me, right? Okay. So now we need to make sure that we have a table inside a Postgres called sales. Now, when you do the Docker compose up, this will automatically create a table inside a public schema. Okay. Now open up any client tool if you want to verify. I'll show you the steps here. I'm using PG admin, right click, register, server, and I'll say local host. I'll go to connection tab. I'll put local host. Port is going to be 5432. Username Hive, Hive. Password is Hive. And the maintenance database, I think we're going to use Metastore DB, I guess. Let me make sure. I think it should. Let me make sure. Give me 1 sec. I just want to make sure so I think I can probably HiveMetastore. I think it is probably, I believe it's Metastore, but I just Metastore. Again, I just want to double check, All right, so in the maintenance database, put Metastore, Hive as username and password. Host is gonna be localhost, click on save. And here you can see I'm connected, okay? Now let's go to database, and then you can head over to Metastore, go inside schemas, then expand tables. And then here on the bottom, you will see a table called sales. So right click and click on query tool, select everything from public.sales. Run this and you have some data, okay? So that's that. Hopefully this should be there as you spin up the stack. Now, the first thing that we need to do in the diagram, we need this Debezium Postgres connector, which will bring the CDC events into a Kafka topic, okay? So here is how we do that. You will head over to this UI, localhost 3040, click on Kafka Connect UI, click on this button, click on new, and then on the search for Postgres. Click here. Now in the project, you will see a folder called Debezium. Inside there you have a Postgres. So here all we do is here we just simply define that the database name, the username, the password, and the table that we want to bring data from, which is public.sales. This one is very, very important, and I'll tell you why. Tombstone on delete set to false. If you do not do this, so the deletes, when you delete something from Postgres, that deletes won't happen on the Hoodie transactional data lake, right? Or your universal data lake. So this is very important, okay? And then just a standard setting, right? So copy this, head over here, paste it, and then click on create. Now we have that. Now what you want to do is again go to localhost 3040, go to topics, Kafka topics, and try to search for the word sales. So now I can see hive.public.sales. Click here, and you should be able to see the sample data from our Postgres. It should be in the Kafka topic. Here you can see we have that data, right? Okay, great. So now that's that. So we basically made the Postgres connector. So at this point, anything that you do in Postgres, the Debezium Postgres connector will publish that to a Kafka topic. Usually the way it follows is the database name dot schema name dot table name. Okay, just want to make sure that I cover that. All right, guys. Okay, good. Now again, you can head to localhost 3040. Here you can see the schema registry, and here you can search for the word sales. Here you can, same thing, right? Here you can see, you can read the particular schema, right? Make sense? Okay. All right, so now that's that, which means we have Postgres, we have some table, we have Debezium Postgres connector, which is publishing data to Kafka, we have schema registry, right? Now let's learn about the Hoodie streamer part, which is the main component of the project, right? So now I will go to Spark submit job. Okay. Now I will take a decent amount of time to explain you all these. Okay. So let me collapse this. Okay. So now we want to ingest data from Kafka into our Minio buckets, right? So line number 21, Spark submit class or.apache.hoodie.utilities.streamer.hoodie streamer. Packages, we use two packages. Since on my computer, I have Spark 3.4. I use the Spark Hoodie bundle package 3.4. But if you're using a different Spark version, simply swap this, okay? And then I use the AWS Hadoop package. After that, I provide the Spark config.property file. This is where I define my Minio access, secret, S3 endpoint, and I set the Spark serializer to or.apache.spark.serializer to cryo serializer. I am giving 1 G of memory, jar files. This is how you would provide the external jar file. We need two jar files, right? The Hoodie snapshot bundle jar and the Java client jar. This helps the DeltaStreamer to perform after every single commit to build the metadata for Iceberg and Delta. This is the path where you will see our main jar file, the Hoodie utility slim bundle jar. This is used for the DeltaStreamer. Table type as copy on write. You can either change this to merge on read, okay, based on a use case. This is the path to our Minio bucket where we want to build our universal data lakehouse. Inside the bucket warehouse, we want to create this folder structure. We are running the DeltaStreamer in an upsert mode. The target table is going to be sales. We enable sync. We want to sync it, right? We enable the Hive sync because we want to sync as we ingest data. After ingesting, we want to sync the data to the HiveMetastore. So for that, we pass in a flag called enable Hive sync. Sync tool class, we are using io.onetable.hoodie.sync.onetable sync tool. Source limit, we set to how much data you want to read from the source at a go. Now source class, since we are using the Postgres, so the source class is set to or.apache.hoodie.utilities.sources.debezium.postgres debezium source. The payload class that we're going to use is going to be Postgres Debezium Avro payload because that's what Debezium will publish, right? Now, this is something that you can change, minimum sync interval, which means after how many seconds DeltaStreamer should ingest new data from the Kafka topic. I set that to 10, which means after every 10 seconds, if there's new data in the topic, it will ingest the data into the Minio bucket. -- continuous, meaning that I want to operate the DeltaStreamer in the continuous fashion, which means it should be running 24/7, right? This is event origin timestamp. So whenever the data is published into Kafka, there's this column which we will use for dedupe purposes, right? It's a timestamp attribute. We provide the bootstrap server. It's running locally, so localhost 7092. We provide the schema registry URL. This is the base URL for the schema registry. And then you have to provide the schema registry URL. So as you can see over here, I provided the schema registry URL, because otherwise how would DeltaStreamer know what is the schema, right? So we have to provide the URL. So if I copy paste this URL on Chrome, where is my Chrome, guys? Give me one sec here. Here you can see the schema, right? Usually this is the format most of will follow. You will have the domain followed by the port, subjects, then the database name dot schema name dot table name hyphen value version latest. That's how it is. Okay. Then after that we set hoodie DeltaStreamer source Kafka value deserializer class. We set that to io.confluent.kafka.serializer.kafka avro deserializer. Okay. Now the Kafka topic offset is set to earliest, meaning let's say something broke and when you restart it, it's gonna start consuming message from the earliest one, right? You can also set this to latest or a custom offset that you like. For now, I set it to earliest. Record key, I'm using the primary key for Postgres. In Postgres, the primary key was sales ID, which is an auto increment, right? So I set that to the record key. I'm not using partition, but again, you can partition your hoodie data lake. I'm using a timestamp attribute. So whenever data is published by Debezium, you will have these column, right? That is something I'm using to dedupe the records. hoodie.onetable.format.toSync delta and iceberg, which means after every single commit, which means once the data is written into the hoodie format, now it will start building the metadata for delta and iceberg. I set the metadata to true, and I'm going to index the metadata in an asynchronous fashion. And then since we are using the HiveMetastore over here, right, which is running on the Docker, we provide the HiveMetastore URI, which is localhost 9083. The database name is going to be default. The table name in the Hive is going to be sales. Okay. And then that's about it. So now once I run this command, you will see after every 10 seconds, the DeltaStreamer will ingest the data into our Minio buckets. So what we will do now, before we run, give me one sec. This video is going to be long. I told you like from the start itself. All right. So now let's copy this. So I took a decent time to explain you this, okay? So on the top of the screen, first I need to open up a couple of tabs here. So first of all, I wanna start my Jupyter notebook here. So I will start Jupyter, because I'll show you how to query this data using Trino, right? So I'm starting my Jupyter notebook, which is started, but again, it's on my other screen, as you can see over here. I'll bring this here once when it is needed, okay? Now over here in this terminal, let's minimize this. Over here, in this one, I'll actually open up one more because I'll be running the I'll be building the multimodal index also, right? So for that, let me just do pwd, and I would basically wanna not this one, the terminal on the bottom section. Let's cd into that, and I need to set my Java home, and then we can start doing some action. So let me, okay, I will zoom in as much as possible because I know people do watch from the phone and YouTube and stuff. So trust me, I take care of all these small details while I'm explaining, right? I'll zoom in. Okay. All right, so guys, now I'll paste this command, okay? The Spark submit command. So let's copy this entire command. See, I'm not doing anything crazy, right? I'm simply pasting this command on the terminal, okay? So now, let me clear, right? So I'm gonna run. As soon as I run, what you will see is you will ingest data from our Kafka topic, okay? Ready? Run. And this is running in a continuous mode, okay? Which means after every 10 seconds, it's gonna sync the data with our HiveMetastore. So let this run in the background. And what I wanna do in the interim, open up your Chrome, go to your Minio bucket and go to Object Browser, Warehouse, and refresh. Here you can see the database default, table sales, and you see the metadata. This is the iceberg metadata, hoodie metadata, and the Delta Lake metadata, okay? So as you can see, my DeltaStreamer is now continuously running and is trying to look for new data from my Kafka topic. Okay. So now, again, it will also sync the data with the Hive Metastore. So now, ideally, I can start running my Trino queries. So let me open up my Jupyter notebook. First, make sure you install these two libraries, pip install Trino and then pip install IPython SQL. So first, I'll, this is my connection URI, Trino. The username is admin, localhost 8080. Okay, we run that, and then we say show catalog, and I can see my Hive and Hoodie catalog. So we'll select the Hoodie catalog, and inside there we have a database called default. Okay, now we can do show tables. We can see sales, right? Now I'll run the query, select everything from sales table. We have 1, 2, 3, 4, 5 records. And what I want to really show you, which will amaze you, is like we have 4 records here. Now, what I'll do here, guys, I'll update something here on Postgres. You will see this real time flowing into our data lake, and also the changes are reflected within less than 2 minutes, guys. This is really amazing. So coming here, okay. So this one, right? I'm simply gonna add star. So before I click save over here, right? I wanna just bring this data. As soon as I save, an update is done. The Postgres Debezium connector will publish that to Kafka. DeltaSTreamer is ingesting. It will read the schema from schema registry. It will do the changes on the data lake. It will sync the data to the Hive catalog, and we can real-time query this using Trino. Okay. So rock and roll. Where's my Postgres? Here, right? So now I'm gonna click this button. Okay. Again, my DeltaStreamer is running in the background. Look, it's running. It's basically syncing after every 10 seconds. Here you can see, right? After every 10 seconds, it's syncing, right? So I made this update, right? At this time, this update must have flown through the Kafka, and the DeltaStreamer must have ingested. So here I'm on the Trino. I'm just running my SQL query. Look, guys, star, and look at the Postgres also. Here, you see that change was flown in real time, right? You saw things in action. Well, great, fantastic, boys. That's great. Now we can also let me show you the delete part. So let me actually copy the SQL query. Okay, I'm gonna go here. Okay, so first let me go to Trino. You see sales ID 1, 2, 3, 4, 5, right? And same in this one. So I will delete the number 1, sales ID number 1. I'm gonna delete that. Okay. So delete from public.sales where sales ID is 1. I'm gonna delete that. You will see that this data was deleted from the Hoodie as well. The DeltaStreamer is taking care of all the things, and it's syncing the data with our catalog. So I deleted. Okay, I just fired it. Now at this point, after every 10 seconds, again the changes must have flown through the Kafka. Again, I think it's already done. So okay, I'm gonna run this query. Now what we expect is this record number 1 should be gone. Okay, ready? 3, 2, 1, let's run. Look at that, gone. It is gone. So not only insert updates, but deletes are also synchronized with this. So hopefully made sense. Well, great, Samuel. This is really fantastic what you are showing us. Well, you can also read this data as Delta Iceberg now, right? DeltaStreamer is continuously ingesting data, right? So let me show you. So if I do read delta.py, this is the path where our data is, right, on our Minio. So simply we create a Spark session, and then again I'm just reading this table as delta. So again, since it's a universal data lake, right, so I should be able to read this as a delta as well, read underscore. So if I do this, look, I'll see the data frame, right? So using Spark, I'm also able to read this data now as delta. Look, that record number 1 is gone. It's not there here. It's syncing things very well, very well. So let me also show you how you can probably query the same data as delta from Trino, right? So for that we need to register the table in the Hive HMS, right? So I'll basically copy this Spark SQL. Okay, and now let me see if I have a terminal open there. Okay, so let me paste this command over here. Okay, this will start my Spark SQL shell. Okay, so show databases, I can do that, and I should see all the databases. Here you can see I have default. Now what I want to do is I want to create a new schema called delta_db. So let me go to my Spark SQL. Okay, so that's done. And now I want to use my delta DB, and I'll show you through Trino as well in a sec. I'm just registering the table in the HMS. Okay, so once that's done, I don't need that. So all I'm gonna do is say create table delta DB, that's the schema that I created. I'm giving it a name that I like, delta_sales. I'm using the word using delta, and I'm providing the location to my universal data lake. Where is my Minio? Here. So if I go to my Minio, here you can see I have the metadata for iceberg. I also have the metadata for delta lake, right? So I simply need to provide the location and register the table in the HMS. So I copy that, I'll show you. Paste that. Now the table has been registered. Now if I head over to my Trino at this point, I think I just have to, let me show you this here. So let me click on, okay, so delta, and then I'm gonna say show catalog. So I have all these catalog. Now I'm gonna use the catalog delta. Okay, so let me see, show tables, this one. So I'm gonna copy this, easier to copy paste, and then here I will say delta, right? I want to use the catalog delta, and remember we created a schema called delta DB, right? That's what we want to use. So coming back to Jupyter, I did that, and now I can do show tables. So I should see all the tables in that particular catalog. I can see that I can see that delta_sales. Let's see if I can run the SQL query. Select everything from, there you go, guys. So I'm able to read the data now as a delta as well from Trino. So you see how easily you have implemented this project. It's not difficult, it is easy. If you have the right settings, if you have the right configuration, it is actually very, very easy. So now to learn this I encourage you, please take out some time, go over the settings, try this out by yourself and see everything in action. That's one of the best way to learn anything in my personal opinion. That's all for the video. Hope you enjoyed. Hope you had fun learning something new in this video. All the resources could be found in the GitHub, the code, the exercise, all the settings. You can open up folders, see what it is, etc., right? So that's all for the video. A simple like on the video will be really appreciated, and if you can share the video with your coworkers and colleagues, that would be great as well. Now that's it for the video. If you have any questions on this project, you can leave the question in the comments, and I'll try my best to come back to your question as soon as possible. With that being said, keep smiling, keep programming, and I'll see you in the next video.